give you 18 minutes, okay? Hi. 18 minutes for him.
Okay, good.
Oh, sorry, you don't have this.
Okay, get mic'd up. Perfect.
I can just do without it. Quit.
Okay. Okay.
Yeah. Oh, it's working. Yes, hi, everyone. My name is Jawad Nasrullah. I will continue the same thought that you have heard in the last two talks, but I'll take it a little bit further in terms of how we are thinking about developing some initial ecosystem and what activities we have done so far. So my talk will be roughly in 4 sections. I'll first take a step back and tell you what are chiplets and why do we care. I'm sure you already know this, but it's good to think about it a little bit before we dive into collaborations that are going on in the industry, standardization activities, and what is it that we are doing in terms of seeding. So chiplets is a very interesting concept. It has a number of benefits, but I will point out a few. But before I do that, here is the thing. We already have chiplets shipping. Last year's top 500 machine is built on a CPU that is all based on chiplets. The only thing is all these chiplets that you see in there, in that chip, they're all designed by AMD themselves. So if you think about that package, think of it as a miniaturized printed circuit board. And think of those chiplets as components that just get placed on it, right? So why did they do this? That's a very important question. So in OCP, we have been working on this topic for about 3 years, and we've made a lot of progress, and I'll touch on that a little bit. And that's not it. Last year, Apple shipped their M1 Ultra has 2 chiplets. So just to visualize it correctly, they did half and half break of their die into 2 and piece those together. And if you look at the cross-section, you will see that inside they're embedding interconnect to connect these 2 things together. So it's an advanced package. So our vision really is that this can actually seed a market where chiplets come from different vendors. And then there are third parties that can just make these miniaturized PCBs, if you want to call it that. So what I'm showing here is the manufacturing of silicon chips is done on wafers. And what we typically, as silicon designers do, we design these bigger and bigger dies that are more performance keeps going up and up. But what happens is if you make a die really large, the number of defects that are coming in, you do a little calculation, you will see 44% dies are being lost. But instead, if you manufactured it a slightly different way, by making smaller chiplets that you can piece together on a package, your yield loss, dramatically can improve. There are other ways of doing it. In wafer scale integration, people have used software to work around, but this is very well understood methodology that companies like Intel and AMD grasp finally, and that's what they are doing. So if you look at that distribution of the defects on a wafer and create a statistical model, there's a very famous one, Bose-Einstein statistics, that chip designers use to come up with the yield. So on this table, on this chart, this is the year, and here is the normalized cost. And the way this is done is, so you'll see two curves. First curve is for a monolithic chip that is 20 millimeters on the side. And then there are some assumptions on how the cost of silicon goes up in the next 10 years or so. And the same design is then broken into 4 chiplets. If you look here, 10 years from now, we are probably looking at 4x improvement. And this is a very important foundational thing in why we are going in this direction. Another important thing is time to market, which is just like DJ was touching on this topic, that with domain specific, we need to continuously improve things. So today, if we design a chip, it takes us finite amount of time to do single chip design and a whole bunch of other productization activity. However, if we do it with chiplets, now we don't have to design the whole package. We only have a new chiplet that we just replaced. So we cut that time. So if we have a chiplet marketplace, say economy, this actually plays into the concept of domain-specific acceleration. So taking a step further into the collaborative landscape, here is the vision. It's actually redrawn chart from that Cliff was showing. So the idea would be that we want to have a marketplace such that there is some kind of a chiplet library available from multiple vendors. No one guy will excel in every single thing, but there will be many companies that supply these components. And then we have system designers that basically aggregate these and go to manufacturing, which is different types of advanced packaging and solutions that are becoming available. And then finally, we have all these applications that we briefly touched on, primarily in HPC and AI. But the reality is there are use cases, legitimate use cases, where it just makes sense to design with chiplets. So just like Cliff mentioned, we're not the only ones in OCP doing this work, but we were the first one. This work was started, we were the first organization that took the step further, and then there were some others that joined us and started developing roadmaps, and now there are a lot of folks working on it primarily to get government funding, right? OCP, we have purely focused on the concept of enabling a marketplace. And like Cliff mentioned, we did the die-to-die interconnects, but one very important thing that I want to touch on or dive deep into is chiplet design exchange and why is it that we started this activity. So what we are trying to do in chiplet design exchange is basically enable design automation. Because if you look at the board design today, you're looking at components that have few thousand IOs. Here we are talking about million IOs in every chiplet and communicating with each other. So the idea was create digital machine-readable models and tools such that automation can be done. So we came up with this thing called CDXML, which is a way to describe chiplets, and then now we are taking steps further. So I'll tell you 3 things. We, a couple years ago, wrote a description on what would an ideal chiplet design kit be. So if you were to sell a chiplet, how would you give the specification along with it? So that's available on the OCP website. CDXML, which is the description model, think of it as data sheet that you today get in PDF format. This will be all machine readable, and this is in collaboration with JEDEC, which means that next several decades, the description that we have that's being defined will be part of the component models that industry will use. And then the next thing that we are working on, which is current activity, is design workflows. I'm not going to touch on that one today. But the idea is that this helps us create catalogs. It helps us enable vendors, EDA suppliers, IP vendors. And then we go into all the manufacturing-related things. So if you are interested, take a look at the modeling white paper. It's also accessible from the main webpage. But the idea here was JEDEC today defines the standards for how to describe electronic components, and they saw the need for how to describe chiplets, and that's why this is active collaborative work that is ensuing. So if you want to find or want to download the specification, you can just go to GitHub and look for it, or take a picture of this slide here. You will also find some detailed presentations that have been done before. So this was CDX that we did. So now what happened is, a couple years later, some of us actually started doing some commercialization work on it. Not everyone from ODSA, but we said, OK, let's try to generate some business, and let's make an alliance. So we made a commercial alliance because we could not really participate with big-name companies. So we said, OK, whoever has the capability, just let's come together and collaborate with each other. So we did find some manufacturers to partner with some designers. And that's this thing that we have been working on recently. That is what we call Chiplet.us. So basically, the 3 design companies in this alliance, we are all like part of the CDX. That's how we kind of like came together. And then we went out there and enlisted some of the new designers, new manufacturers, and some of the established ones. So we can now technically take a specification and go all the way through to the manufacturing with this one. So this is our next activity that we are working on right now. And I want to point out a couple of things here. So one of them is, if you look at the heterogeneous integration manufacturing, it's quite complex. There are a number of manufacturers available along the supply chain. And there are a number of software companies that come at the stage of design automation and later stage. But roughly, this is a very simplistic view, which is there are some people who are manufacturing components that are chiplets, and there are some folks who collaborate to do the system integration. So our alliance starting members are basically taking care of the system integration. And we have folks who are trying to develop substrate technology. This in particular in US in the context of US CHIPS Act. And then these guys are established players in Silicon Valley in that area and San Diego. So we also right now are working on inducting some of the new chiplet suppliers into our ecosystem as well. So here is an example. This is pretty much the last slide of this one. So look at the system. This is actually an integrated circuit and one of the example demonstration system that we are trying to build. So the idea is it's actually a multi-layer type of design. And at the very foundation is power management and the control. And the next level is computation, and the last level is I/O, which is mainly through the optical. Now, the challenge in doing this is heat removal. And it's a pretty serious one, right? So if we just look at this thing, the very first thing we do is just make sure that our thermal in spatially and in time domain is working out okay. That's not the only problem. This is a very ambitious thing that we are trying to do, but the good thing is that there is some support available from US government at this stage to do try some of this out. But imagine that here you can compact a lot of performance and combine that with immersion cooling. This basically will be a very interesting thing, right? So just the last slide, we, Chiplet.us, really are looking at solving the next generation chiplet and heterogeneous integration problem and providing a option to folks on where to go and get this thing done. Because today, if you want to do it, your option is go to Intel or AMD, right? But we'll be doing this thing commercially. Please join us in CDX workstream. You can find us on the ODSA wiki and OCP wiki. We meet on Thursdays, 10 a.m. Pacific time. And just like every other work stream, we are open. Just dial in. Thank you very much.
Thank you, Jawad. Okay, I think we have our